test. On number one, it was just a matter of identifying that there was a common factor in the numerator and denominator, getting that out, and because there was a common factor, you could cancel that. So I could cancel this and this. Now there were two restrictions for the domain, and it had to go back to the original expression, right? In this expression, x may not be 0, and x may not be positive 2, because that would produce a division by 0 undefined error. So that's the answer I'm looking for, 4 over x, and again, it's factoring. Next problem, did you understand how to turn a division problem into multiplication? You see I very carefully rewrote the 3x to the 5th, and then below that 2x to the 4th y, multiplied by the reciprocal. Now, the problem that I saw is several of you lost track of things, right? So you've got to be really intentional with your handwriting. Try and be careful. And even here, I might lose the fact that I have 5 factors of y, and I might just see that as a y only. But be real careful because you don't want to lose things. There was a common factor of 2 and 3. There were 5 common factors of x, and there was 1 common factor of y. So when I cancel all those common factors, I was left with xy to the 5th over 3. Number 3 was really interesting. A lot of people made some similar errors. This denominator, right, this one right there, the x squared minus 2x minus 3, factors as x plus 3 times x plus 1. That means that the other denominator needs a factor of x plus 1. So you can see right here, I'm adjusting this denominator. I'm multiplying the top and bottom by x plus 1. My denominator becomes the same, right? They're both x plus 1 times x minus 3. My numerator for this part becomes, what do I get when I multiply x plus 1 times x plus 8? And when I multiply that out, it was x squared plus 9x plus 8. Carefully multiplying the binomials. On the other side, and I had this error, this 9 didn't print on my original answer key. On the other side, I'm left with just a minus 5x minus 29. Now, I combined all my like terms, and I got x squared plus 4x minus 21. And it's over that common denominator of x plus 1, x minus 3. That numerator factors, and once it factors, it revealed that there was a common factor of x plus 3. I eliminate that. This problem did not ask me to state restrictions on the domain. If it did, I would have said x can't be negative 1 and x can't be positive 3. Next problem. By the way, number 1 error on this test was right here. A lot of you looked at this and you factored it. You just insisted that was 3 times the quantity of x minus 3. And you forgot that too. So look at your test real closely and see if you drop that out. This factors as 3 times the quantity of 2x minus 3. And the other thing is this. Look, I've got this numerator divided by this denominator. So you can see I just rewrote the numerator, and then I flipped the denominator, right? It became 3 times the quantity of 2x minus 3 over x minus 3x plus 3. There were common factors, both had a 3, and both had a common factor of x plus 3. This said, assume that all expressions are defined, so you didn't have to tell me that x can't be 0 or 3. All right, question 4 is, no, that was 4, 5. 5, one of the most liberating, beautiful things you could do is just look at things in their factored form. Those of you that multiplied both sides, and look, it became really simple once I realized that left-hand side had a common factor of x minus 3. So once I factored that numerator, got rid of the common factor of x minus 3, my equation became x plus 4 equals 15. Subtracted 4 from both sides. Some of you had this step. Some of you literally had this, and right below it you wrote 9.
What?
9. You wrote x is 9. 15 minus 4 is 9. Look, guys, I can't help you. You have to slow yourself down. I might make a mistake like that, but I will always catch it when I take 11 and I plug it into this equation. Right? I'm going to catch that mistake. A lot of you just write that down, and I only took off a point for it. Did you do that?
No, I got it right.
Okay. Okay. Next one. Number 6 asks you to write this in radical and simplified form. This, in radical form, it's 16 squared, the cube root of that. Now, when I write 16 squared out, notice what I did. I wrote 16, which is 2, 2, 2, 2, right? 2 times 2 is 4, 8, 16. I've got 4 factors of 2, and then 4 more for 16. Then I'm looking, because it's a cube root, I'm looking for groups of 3. So there's 2 groups of 3 that I can bring out. So outside of my cube root, I've got 2 times 2, which accounts for this 4. And then I've still got a cube root of 4 left behind, a cube root of 2, 2. Let's see, number 7. I just want you to write 12 to the 3, 7. I tried to simplify that out, but you can't. There's nothing there that you can do with it. Or is there? No, I counted. There was nothing there. No, there were no factors of. There were nothing that had 7 factors inside of there. Number 8. Several of you. What I saw some of you do. It appeared that you. Now you. Yeah, I divided by 4 first. Then I took. Some of you squared. A couple of you did this. A couple of you squared the right side, and you wrote. No. What did you do? Squared the left side and took the square root of the right. Did you do that? Yeah. And I was trying to explain. Look, guys, you're doing the same thing to both sides. Realize if you square one side, take the square root of the other, it's out of whack. Now, a couple of you did this. A couple of you decided, well, I'm going to square both sides first. And you could do that. You can write 16 because I squared this. No, yeah, that. And then times x minus 3. And that equals 64. If you divide both sides by 16 and then add 3 to it, you get 7 also. But you can see what I did. This next one, simplify the expression. So I wrote everything out inside. It was 64, which is 8 times 8, so it's 2, 2, 2, 2, 2, 2. And then I wrote out my 3 factors of x. It's a cubed root. Because it's a cubed root, because it's a cube, I made an error. This is a mistake. That's why this line's right here. Because it's a cubed root, these should both be 2's, right? That's right. This should be 2 and this should be 2. Therefore, that's a 4x. And 4x divided by 2 is the 2x. Yeah, you could do that first. So 64 over 8 is 8. So you could simplify it this way to start with. You could write 3 times, that's nicer. 3 times 8x cubed, and that's immediately, right? Is that what you're saying? Can you divide this first? Yeah, you can do that. 64 over 8 is 8, so this immediately becomes that. Cube root of 8 is 2, cube root of x. Oh! And you actually can do that too. You can rewrite this as the cube root of 64 over 8 times the cubed root of x cubed, right? We have a thing that says the product, the radical of products is the product of the radical. You can, yeah, so that works, and that immediately gives you the x, and then the cube root of 8 is 2. Number 3, factoring is huge, right? Factor the numerator or denominator. There's a common factor of x minus 6. X may not be negative 6. No, that's not right. X can't be positive 6, can it? Right?
Yeah.
X can't be positive 6. I didn't get that. This is not the key I graded with. The key I graded with is in here. Number 4. Okay, so number 4, first of all, I factored that. And then I realized, I'm sorry, number 11. Then I realized that I needed an x minus 4 over on this one. So you can see in green, I'm introducing the x minus 4 over x minus 4. The numerator of the first one is 2x squared minus 48 minus, this is kind of important, right? Making sure that you've got the minus with the parentheses, because this negative needs to be distributed to the negative x squared, the negative 2x, and the negative 4. When we do that, and I simplify my numerator, I get x squared minus 2x minus 24, which factors as x minus 6, x plus 4. There's a common factor of x plus 4, so the answer is x minus 6 over x minus 4. X may not be plus or minus 4. This one was simple to get the solution, right? X is 3, but the problem is when you plug 3 back in there, that makes division by 0 error, so there's no solution on 12. And more than half of you got that right. Most of you got the 3 and then said it's no solution. Number 13, I was shocked by how many of you got this right, to be honest. Some of you are like, you're developing like this ability to cope with these. So you can see I've set it up with Heath, I've set it up with Leo. I don't know Leo's rate, but I do know together it takes them 3 hours, and together their rate is 1 over 3. So you can see here I wrote this together equation, 1/5 times 3 hours plus 1 over x times 3 hours. What I'm saying in this equation right here, what I'm saying with that equation is they're working for 3 hours, and they're working together. So for the 3 hours they're working together, I've got Heath at 1/5 is his rate, and I've got Leo 1 over x is his rate. So that's the equation that lets me solve for x. X is 7.5, so it takes Leo 7.5 hours. His rate is 1 over 7.5. And again, if you want to copy the details of that, that'll be there. Just pause the video. Number 14, I'm scared that, on number 14, I had to completely change this because the answer key is wrong because there was an 8. Didn't you guys have an 8? Wasn't it minus 18? Yeah, I don't know what it is, but I basically print these to OneNote, and it was dropping out some characters. It dropped out that 8. So this is the wrong answer, and I didn't rewrite the right answer here. The right answer is, that's right, the correct answer is x is 13. And I don't know that I'm going to pause this and do it. Oh, no, this is the correct work, isn't it? Yeah. Oh, okay. I originally had the wrong thing, but I came in and changed it. X is 13. So I did this correctly. The bottom does factor as x minus 9 times x plus 2, and then it equals the other thing. Both of those it becomes a lot simpler if you decide to multiply both sides by x plus 2 first, because then those extra factors in the denominator drop out. So it became the proportion 2 over x minus 9 equals 6 over x minus 1, and I solved that x was 13. And 13, by the way, plugs back in. 13 doesn't create a problem. The only values that would create problems would be positive 9, negative 2, and positive 1. 13 is not any of those, so I'm good. Number 15, I began by squaring both sides. Make sure when you square both sides that you're squaring that binomial. It's x plus 1 that gets squared, which is x squared plus 2x plus 1. When you solve this, you get two answers, right? You get positive 4 and negative 5, but when you plug negative 5 into this problem, it doesn't work. So I took off a point if you gave both of those. Okay, the last one, I want to just pause this and look at it. So a couple things I did was, first of all, I began by factoring this beast, right? And that's the most important thing you need to do when you see a problem like this on the retest, is factor it. And the reason why I factored it, when I'm looking at this in the factored form, everything that I can see is right here. First of all, I know because I have a factor of x plus 2 in the top and bottom, that x equals negative 2 as a whole. The other thing that I know is that this value right here, x equals positive 1/2 is my only zero. It's the only root. It's the only time that it crosses it. And my asymptotes, right, forgetting this one's out of the picture because I know that's just a hole. X is 0 is an asymptote, and x is -5 is an asymptote. So I come in and I first of all add these features, right? I put this dashed line at -5, a dashed line at x equals 0 because those are asymptotes. I did go ahead and put in there's this hole right here at -2, and I put an open spot on that graph to see the hole. The only place where it crosses is right here, right? This is when x equals positive 1/2. So it pops up and then it slowly kind of trails off there. The other one, if you look at it, the degree of the numerator is less than the degree of the denominator. Whenever that's true, the line y equals 0 is a horizontal asymptote. So I've also got this dashed line. Please, some of you desperately, look, if your whole thing is you're just like, oh, okay, I'm just going to do something like this here, this and this and this thing, right? Look, some of you desperately need to realize that there's confines, right? Don't just, anything that you write here is that this is just annoying, right? So draw those asymptotes and then keep your curves in the confines of it. Look at your calculator. It gives you the general characteristics of it. But for you to do this on your function, and some of you did it, you had this and you went like there, and then you went whooting down up here and this. Look, for you to do this indicates you don't understand that's an asymptote. Hey guys, tonight, your homework assignment is to go over this test, review the test video if you want to, look at these, and I